Good morning. Myself, Dr.V.Balasubramanian, Assistant Professor from P.S. College of Engineering and Technology, School of Basic Engineering and Sciences. Today we are going to discuss about rotary mechanical pump. It comes under thin films. So let me give an introduction to thin films and what is meant by vacuum pumping methods. Next we are going to discuss about positive displacement pump, followed by the rotary pump, piston pump, vane pump, its merits, demerits, and then it is end up with the conclusions. So why is a vacuum is needed? So we are since we are discussing on the research aspects, to synthesize a semiconductor material or to synthesize any class of material for solar cells and other optical related applications, we are going to deposit a semiconductor material or deposit a material using a physical vapor deposition method or chemical vapor deposition method. So in particularly we are concentrating on physical vapor deposition method. So for physical vapor deposition method, a vacuum is a most important to deposit a class of material on the conducting substrates. So here scientifically speaking, so why is a vacuum needed? It is a vacuum is needed to move a particle in a straight line over a large distance. So because of achieving vacuum, the particles were uniformly deposited and it is uniformly moved in a straight line over a large distance. So that is why we need vacuum. So as I said earlier, so there are different vacuum pumping methods are available. So generally a vacuum pump is divided into two types, that is gas transfer vacuum pump and then entrapment vacuum pump. So this gas transfer vacuum pump is further classified into two types, that is positive displacement vacuum pump and then kinetic vacuum pump. Here also the entrapment vacuum pump is classified into the different types. It is classified into adsorption pump, cold trap pump, and then further it is classified into getter pump and bulk getter pump. This getter pump is classified into getter ion pump. Then this entrapment is further leads to sublimation pump, evaporation ion pump, sputter ion pump, cryo pump, and then finally it is end up with the condenser. So we are concentrating on only the positive displacement vacuum pump and kinetic pump, and especially today we are going to discuss about the positive displacement vacuum pump, in which we are going to discuss about the rotary mechanical pump in detail. So before that I am going to give an overview of positive displacement vacuum pump. This positive displacement vacuum pump is further classified into two types, that is reciprocating displacement pump and then rotary pump. So this reciprocating displacement pump is classified into two types, that is diaphragm pump and then piston pump. Then the rotary pump is classified into different types, that is liquid ring pump, rotary piston pump, and then sliding vane rotary pump, multiple vane rotary pump, and then rotary plunger pump, and finally it is classified into dry pump and root pumps. So these are all the different kinds of vacuum pumps available under positive displacement vacuum pump. In the case of kinetic vacuum pump, it is broadly it is classified into three categories, that is drag pump, fluid entrainment pump, then ion transfer pump. So this drag pump is classified into again gaseous ring pump and then turbine pump. Here the fluid entrainment pump is classified into ejector pump, which was further classified into liquid jet and then diffusion pump. So diffusion is further classified into different types, that is a diffusion ejector pump and then self-purifying diffusion pump and then fractionating diffusion pump. So this drag pump is classified into gaseous ring pump, which is then followed by turbine pump. This turbine pump is further classified into axial flow pump, then it is a radial flow pump, and broadly it is classified into molecular drag pump and then turbomolecular pump. So these are all the different kinds of vacuum pumps available under positive displacement vacuum pumps, kinetic vacuum pumps, and then entrapment vacuum pump. So for physical vapor deposition method, that is for thermal evaporation method or pulse laser deposition method, wherever we are going to deposit semiconductor material using physical vapor deposition method, definitely these pumps are found to be definitely it is present inside the system. So most importantly, rotary mechanical pump is always there, diffusion pump is always there, turbo molecular pump is also there. In some cases, people are having spud-ion pump and the other getter pump and cold trap pump. So these are all the different categories. But the rotary mechanical pump, turbo molecular pump and the diffusion pump, these three are essential and it is always exist inside the physical vapor deposition system. So in which we are going to discuss about the rotary mechanical pump in detail. So what is positive displacement pump? So it is working under a principle. So during a cycle, a given volume of gas at low pressure is trapped mechanically and it is subsequently compressed to the exhaust pressure. So this is the principle. This positive displacement is working under the simple principle, that is during a cycle, a given volume of gas at low pressure is trapped mechanically and subsequently it is compressed to the exhaust pressures. So during this process, we have experienced two difficulties. So what are those two difficulties means? This swept volume has to be sealed in order to ensure a good compression ratio. Hence, an efficient dynamic seal has to be provided. So sealing has to be most important in the case of positive displacement pump. Then the compression of the gas during the pumping cycle creates heat which must be evacuated. So that these are all the two difficulties. Sealing has to be done properly, and then during the compression, heat may be generated. We need to evacuate the heat produced. Next, the positive displacement pump has an expanding cavity on the suction side and the decreasing cavity on the discharge side. Here, a liquid flows into the pumps as the cavity on the suction side expands, and the liquid flows out of the discharge as the cavity collapses. So it is having a cavity. So when the liquid is entered into the pumps, the cavity will expand. When the liquid flows out of the suction side, out of the cavity collapses. So this is what the mechanism is going inside a positive displacement pump. Here, the volume of a gas, here the volume is a constant given in each cycle of operations. So that is this positive displacement pump can be divided into two main classes, that is reciprocating pump and then rotary pump. So what is meant by reciprocating pump? So typically reciprocating pumps are nothing but plunger pumps and then diaphragm pumps. Those things were already discussed in the introduction part. So anyway, plunger pumps is nothing but it is consist of a cylinder with a reciprocating plunger in it. So in the head of the plunger pump, a cylinder acts as a suction side, and the discharge valves are also mounted. In the suction stroke, the plunger retracts and the suction valves gets opened, causing the suction of fluid into the cylinder. In the forward stroke, the plunger pushes the liquid out of the discharge valve. This is the simple mechanism going on in the plunger pump. With only one cylinder, here the fluid flow varies between maximum flow when the plunger moves through the middle position and zero flow when the plunger is in the end positions. That is simple one. Here it is having only one cylinder. Here the fluid flow varies between the maximum flow when the plunger moves through the middle positions and the zero flow when the plunger is in the end positions. Here using plunger pumps, here a lot of energy is wasted when the fluid is accelerated in the piping systems. So that is the drawback of using plunger pumps. Here a lot of energy is wasted. In the case of diaphragm pump, the plunger pressurizes the hydraulic oil which is used to flex a diaphragm in the pumping cylinder. Here the diaphragm pumps are used to pump hazardous and toxic fluids. So here we can deal with some toxic gases. That is the disadvantages of diaphragm pumps. We also see the disadvantages of plunger pumps also. So in order to overcome these drawbacks, we are using rotary pumps. So we need to see the rotary pumps in detail. So typically rotary pumps are classified into different types, that is gear pumps, lobe pumps, piston pumps, vane pumps, progressive cavity pump, peripheral pumps, and then screw pumps. These are the different variety of rotary pumps available under a rotary pump category. So what is rotary pump? Rotary pump comes under a positive displacement pump. So it displays a known quantity of liquid with each revolution of the pumping elements. So here the pumping elements includes gears, lobes, rotary pistons, vanes, and screws. So we have discussed those things in the previous slide also. That gears, lobes, that rotary pistons is nothing but it is an equipment. So these pumping elements, these are all the pumping elements. So based on this, the pumping elements, whether if we are using lobes as a pumping element, then it is called as a rotary lobe pumps. If we are using piston as the pumping element, then we may call it as a rotary piston pump. If we are using vane as the pumping element, then we may call it as a rotary vane pump. So likewise, we are calling the rotary pumps. Here, the positive displacement pumps are found in a wide range of applications using chemical processing, liquid delivery, marine applications, some biotechnology related applications, pharmaceutical applications, as well as food, dairy, and beverage processing. So these are the various applications of this positive displacement pump, especially rotary pumps. So mechanical vacuum pump is works by the process of positive gas displacement. That is, during the operations, the pump periodically creates increasing and decreasing volumes to remove gases from the system and exhaust them to the atmosphere. This is the working principle of the mechanical vacuum pump. So it is works by the process of positive gas displacement. So during its operations, the pump periodically creates increasing and decreasing volumes to remove gases from the system, and as well as it is exhaust them to the atmosphere. This is the working process. So then this rotary pump is classified into two types again. Then it is classified into different types, but we are going to concentrate on only two types, that is piston type and then vane type. This is the schematic diagram showing the working mechanism of a rotary piston pump. In the rotary piston pump, as shown in the figure, here the gas is drawn into the chamber. When the gas is drawn into the chamber, the keyed shaft, this is nothing but the shaft, the keyed shaft rotates the eccentric and the piston. So when the gases enter into the chamber, the shaft gets rotated and the gases are moving into the chamber and it gets rotated. Here, the shaft rotates the piston eccentrically. Here, when the piston is moving into the chamber, air from the chamber is sucked and it is went out through the exhaust. So this is the process. This process was schematically repeated again and again. So the air from the chamber is sucked inside and it is went out through exhaust. Here the gas is isolated from the inlet after one revolution, then compressed and then again exhausted during the next cycle. So this cycle was continuously repeated. So a gas is isolated from the inlet. After one revolution, the gas is compressed and then it is again exhausted during the outlet, exhausted at the outlet during the next cycle. So this cycle was repeated and then the gas molecules are slowly isolated in order to achieve vacuum. Here the whole chamber is filled with oil in order to remove friction. The evacuation limit of that is rotary piston pump is found to be in the range of 10 power minus 1 to 10 power minus 2 torque. The intrinsic speed of the pump is calculated using this formula, that is SP is equal to V naught Fs. V naught is nothing but the volume of the gas enclosed inside the chamber, whereas Fs is the rotational speed. That is the rotary piston pump. It is having the overall capacity of 30 liters to 1500 liters per hour. So the next one is rotary vane pump. The rotary vane pump contains an eccentrically mounted rotor with spring loaded vanes. As I said already, that they are using piston. So the piston rotates, the gas is coming inside the chamber, it is getting compressed and then it is again exhausted. Here we are using vane as a pumping element. That's why we can call it as rotary vane pump. Here the rotary vane pump contains an eccentrically mounted rotor with spring loaded vents. Here also a gas is coming inside through the inlet. So when the gas is coming inside, the vane pump, that is vane element, getting rotated, then the gas will continuously come inside the chamber. It is getting compressed and then it is again exhausted during the exhaust valve. This is stator A, this is stator B, this is rotor A. So this is the schematic diagram of rotary vane pump. So it is an oil sealed rotary displacement pump. Here the pumping system consists of a housing unit and eccentrically installed the rotor, vanes that move radially under spring force. It is having inlet and outlet valve also. The outlet valve is always oil sealed. The inlet valve is designed as a vacuum safety valve that is always open during operation. So during this inlet valve, gas will coming inside and it is getting isolated, compressed, and then it is going to the exhaust. Here the working chamber is located inside the housing unit. So this is the housing unit. It is having inlet valve, exhaust valve, and the chamber is located inside the housing unit. So during rotations, here the vanes slide in and out within the cylindrical interior of the pump, enabling a quantity of gas to be confined, compressed, and discharged through an exhaust valve into the atmosphere. So this is the process takes place inside the rotary vane pump. So during the rotations, the vanes slide in and out within the cylindrical interior of the pump, enabling a quantity of gas to be enter into the chamber, where it is getting compressed and then discharged through an exhaust valve into the atmosphere. Here the compression ratios of the rotary vane pump is found to be up to 10 power 6 can be achieved. This is the maximum compression ratio of a rotary vane pump is 10 power 6. Here the valve used in this chamber is called as magnetic isolation valve. So by repeating this process, the gas molecules are slowly separated as well as it is isolated and then move into the atmosphere. Thus vacuum is achieved. These are the different stages of vacuum pump. The first stage is induction. Induction is nothing but when the gases are coming inside the chamber, the vane pumps slides in and out. That is called as induction. It works under the principle of Boyle's law. There when the gas is coming into the chamber, it expands in the case of low pressure. The second one is isolations. Here the gas molecules enter into the chamber is getting compressed, that is isolated, and the third stage is compressed using the vane pumping element, and the fourth step it is enter into the exhaust. So this is the overall view of the different stages and working of the rotary vane pump. So here we have adopted Boyle's law. This is both low pressure and then high pressure. So here also we are able to calculate the pumping speed. So to calculate the pumping speed, let us assume that the volume of gas V0, which is present in liters, the volume of gas is enclosed between the rotor and the pump stator housing, and then it is swept into the atmosphere for each revolution of the rotor. Then the intrinsic speed of the pump will be calculated using the formula Sp is equal to V0 into Fs, where Fs is the rotor speed in revolutions per second. Here the vacuum is found to be in the order of 10 power minus 3 torr is obtained. So in order to work with this rotary mechanical pump, whether it may be a rotary piston pump or rotary vane pump, we have to follow some precautions. So that is nothing but it should be free from solid or dust particles. The entire chamber should be free from solid or dust particles. To avoid vibrations, metal bellows are used. The best example is neoprene. And the third case, here a continuous maintenance of oil level is also necessary. At the exhaust, oil leakage is also observed. We need to take care of the oil leakage. And finally, ensure correct tightness in the V-belt. So these are all the following precautions has to be checked before before operating the rotary piston pump or rotary vane pump. Next, let us look into the merits, that is advantages of using rotary pumps. When used by electric motor, it is much faster than the other pumps. And compared to other pumps like turbomolecular pump and cryogenic pumps, diaphragm pump, plunker pumps, if you are using electric motor, it is found to be much faster than the other pumps. It creates a medium vacuum of 10 power minus 3 torque. Here, air leakage is absent. That is the most advantages of using rotary mechanical pump. It occupies a very less space. It can be used as a compression pump also. No fore vacuum is needed to use the rotary mechanical pump. The demerits, it is a qualitative measurement. Continuous maintenance of oil level is necessary because oil leakage has to be observed. So continuous maintenance of oil level is always an important one. Then it should be free from solid or dust particles. So these are all the demerits of rotary mechanical pump. Finally, conclusions. This rotary mechanical pump, as I said, rotary mechanical pump has created a vacuum of 10 power minus 3 torque. So these are all the different types of rotary pumps, that is rotary piston pump, rotary vane pump in single stage, rotary vane pump in double stage. In the case of rotary piston pump, the ultimate vacuum has to be achieved in the range of is 1 Pascal. That is the case for a rotary piston pump. In the case of rotary vane pump for single stage, the ultimate vacuum has to be achieved is 1 Pascal. In the case of rotary vane pump double stage, the maximum vacuum is found to be in the range of 2 into 10 power minus 2 Pascal. In the case of pumping speed, a rotary piston pump is found to have a pumping speed of 30 to 1500 meter cube per hour. That is the maximum pumping speed using a rotary piston pump. In the case of a rotary vane pump, that is for single stage, the pumping speed is 1 to 300 meter cube per hour. In the case of double stage, the rotary vane pump, the pumping speed is found to be in the range of 1 to 300 meter cube per hour. So these are all the overall overview of rotary mechanical pump. Next, we look into the other displacement pump in the next class. Thank you.